In this video, we will review static data, methods, and blocks. Let's discuss the use of static keyword to create fields, methods, and blocks that belong to the class rather than to an instance of the class. First, let's learn about static variables. Static variables are the special type of variable which are created during the load time of a class, or we can say when the class is instantiated. Here, with the new operator, we instantiate a widget. There are occasions when a variable that is common to all objects is desirable. This is accomplished with the static modifier. Fields that have the static modifier in their declaration are called static fields or class variables. They are associated with the class rather than with the object. Every instance of the class shares a class variable, which is in one fixed location in memory. Any object can change the value of a class variable, but class variables can also be manipulated without creating an instance of the class. Let's look at our widget class. Using a static variable to keep the number of widgets the system has created can help us determine availability of stock or control the number of widgets we want to create. Here we have a private int ID and we have a private static int number of widgets. The constructor, when called to initialize the object, increments the number of widgets and assigns it to the ID. Here we see that it's adding to the number of widgets incrementally, but only adding the value of the number to the ID. We also have this method here that gets the ID. We also have a method that is static, which gets the available widgets. The static blocks are the blocks which are implicitly called when the class is instantiated. That means when the instance of the class is made. Let's add a static block to our widget. This static block is executed when the class is loaded or initialized, to be precise. It can be thought of as a class constructor. Note that there are also instance initializers which look the same, except that they don't have the static keyword. Those are run in addition to the code in this constructor when a new instance of the class or object is created. Static methods, such as getAvailableWidgets, have a static modifier in their declaration, and these should be invoked with the class name without the need of creating an instance of the class. As in here, widget.getAvailableWidgets. As we can see, we are not using the instance name w1 or 2. We're just using the class name and then calling the method from the class. Some points about static methods are: static methods are automatically created during the load time of the class. They are accessed by using class name. A single copy of static method is created and shared among all other methods. The most important point: static function cannot access non-static methods members. Now let's run our program and see how many widgets are available. As we can see here, the static block was executed first. Then we were able to get the amount of widgets created, 1 and 2. This concludes our discussion of Java static data, methods, and blocks. In this video, we will review the Java I/O available within the Java programming language. You should have already had exposure to the Java I/O in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. The Java NIO 2.0 has come forward with many enhancements. It's also introduced new classes to ease the life of Java developers when working with multiple file systems. JDK 7 has the addition of file change notifications. This feature, part of NIO 2.0, the Watch Service API lets you receive notification events upon the changes to the subject, the directory, or the file. The steps involved in implementing the API are to create a watch service. Here we have a watch service, we have a path, and we register the watch service with this path. In this case, I'm using ctemp temp. Here's an example. Let's create the directory monitor class named dirmonitor, whose responsibility is to monitor a particular directory. Let's create our watch service. As you can see here, we create a watch service. This service consists of a queue to hold watch keys. These are the watch keys here: entry create, entry delete, and entry modify. While registering, we specify these events that we want to receive. We have to start an infinite loop so we can listen to these events. When an event occurs, a watch key is placed into the queue. We're going to be consuming the watch key and invoking queries on it, such as what kind are they? Let's run our program. At this point, our programming is just listening to the file or directory that we specified in the path, temp.temp. Now what happens if I place a new document in here? We get an event on new text document, number 2.text, entry created. Now we have event on new text 2 is entry deleted. This is a very useful API that JDK7 has introduced. This concludes our discussion of the Java I/O. In this video, we will review the Java wrapper classes available within the Java programming language. You should already have had exposure to the Java wrapper classes in the VTC course Java 7 Language Basics, so we will quickly be reviewing it in more depth. Let's take a look at Java wrapper classes. Java wrapper classes are used to represent primitive values when an object is required to represent a primitive type, and hence plug into an object hierarchy. The wrapper classes are extensively used within the collection classes in the java.util package, and with the classes in the java.lang reflection package. Here are the primitive types above, and here we have the wrapper classes. Since you already know how to use this, here's an advanced performance tip. Wrappers have some overhead associated with them. They offer generality at the cost of inconvenience in digging out the value, and there are some space costs as well. When the need arises to use your value as an object, use wrapper. This method, wrapper.valueOf, because it uses a pool of wrappers, which for performance reasons is preferred over new wrapper. The most common used methods of those classes are the various parse, value, and valueOf methods, because those methods let you turn a string into a primitive. Here, let's do an example of these methods. This method will parse a string Here we're going to wrap a primitive value into an integer And here we're going to get the value of a wrapper class and place it back into an integer reference of primitive type. This concludes our discussion of Java wrapper classes.